Okay, students, today we're going to work with graphing quadratics that are not parent function. Remember, parent function, as we talked about before, is when the vertex, it's called the vertex right here, is at the origin. Obviously, as you see, this one's not at the origin, so it's a transformation. It's transformed, it's slid, okay, or translated to a different spot. How do we know it would be translated? As I've told you before, if there's a bx part, that's going to move it left or right, and if there's a plus or minus in the c, that will move it up or down. Not necessarily those numbers. As you see, it's not plus 25 where the vertex is, but 0, 25 is a point that goes through the x or the y-axis right there. Okay, so that's how you know it's going to be transformed. Remember, the ax squared part right here, this tells me the shape of the graph. So this is 2x squared. It tells me it's going to be narrower, narrower. Remember, I told you the closer the number is to 0, the wider it is. The further away from 0 it is, the narrower it is. Okay, so we're writing it in what's called vertex form. So what that means is the form we're put into, we're going to be able to identify the vertex, this point, right away from it. Well, as you see, y equals ax squared plus bx in vertex form by completing the square. So we just talked about completing the square before, so now we're doing it again right here. Okay, just a little bit different as far as what you do with your C after you create the C, what you need to do. Okay, so how it works. To complete the square, I need to go ahead and I separate these two pieces together. This plus 25 is off on its own. Okay, I need to take out the 2 because I need this to be a 1 right here. So I need to factor out the 2 from these two terms right here. Remember, that's 3 terms there total. So I'm putting the x's together. I factor out the 2. I'm left with x squared minus 6x. And now I have my plus c. Okay, and then the 20 plus 25 is at the end. Well, since I'm adding some number here, and I'm not going to do it to the other side, okay, I need to go ahead and subtract it on the same side. So if I add 5 to the right side, in order to keep the equation the same, I need to subtract 5 also. If I add 10, I need to subtract 10. That way I'm not changing the problem. Okay, so completing the square is still the same as always, 1/2 of b, quantity squared. We just did it earlier, we did it in geometry over and over, finding the center of the circle by completing the square. So 1/2 of b is -3, squared is 9. So I added 9, so I need to subtract, oops, right here. Here's the tricky part. You think it's 9, but what it really is don't forget you're distributing this 2 through here. There's that 2x squared. There's the -12x. I've really added 18. So since I've added 18 to it, I need to subtract 18 to it. Okay, that way I haven't changed the problem. And now I can write it in vertex form. This is a perfect square trinomial of x minus 3. 20 squared, remember you just drop that right on down there. And 25 minus 18 is 7 plus 7. So the vertex now, it's always opposite here and same here. So the vertex is 3 comma 7, and that's what we see right here, 3 comma 7. Remember, the shape of the graph comes from the y equals 2x squared. So that's my shape of the graph, the parabola, 2x squared. So starting at 3, 7, pretend like that now is my new origin, x and y. And if you want to write 2x squared, so you see what you're plugging in. If I plug in 1 or -1 into there, I get 2. So that means if I go right 1, I go up 2. If I go left 1, I go up 2. Okay, and then I can go ahead and put my curve through it, my parabola through those 3 points. If I want another point, I could go 2 and -2, and 2 and -2 squared is 4 times 2 is 8. Okay, and I go right 2 up 8, left 2 up 8, and that'd be another set of points. Okay, so that's for graphing it. Write each equation in vertex form, then graph it. So again, we're doing it without the graphing calculator. Obviously, I can plug all this in graphing calculator and do it right from there. You can check your answer with the graphing calculator, but the point is that you're doing it by hand. So I need to see this work. If I don't see this work, you don't get credit. All right, backside here. Parabolas can be transformed by changing the values of the constants a, h, and k in the vertex form. H comma k is your vertex, which remember is opposite, same. A tells me the shape of the graph. A tells me the shape of the parabola. Nothing else tells me the shape of the parabola, just A. Remember the B, when you have in quadratic standard form, the B, if there's a BX, that just shifts it left or right, and the C tells me it's going to be shifted up or down as well. Okay. Here's where we talk about it being wider or narrower. I said as A is greater than 1, it's further away from 0. Therefore, it's wider. I mean, narrower. Sorry, narrower. And if it's between close to 0, absolute value of A, that just refers to the positive and negative. So positive, it opens up. Negative, it opens down. The closer it is to 0, the wider it is. Okay. The H translates the parabola horizontally. Positive values of H slide the graph to the right, and negative values slide the graph to the left. Okay, the value of K translates it vertically. Okay, I've already explained all this, so now you have it in writing here. So graph this. There's my vertex, opposite same, so -7, 3. -7, 3 is right there. And it's a normal y equals x squared. So that means right 1, up 1, right, left 1, up 1, right 2, up 4, left 2, up 4. Okay. So here we're just doing with more graphing. Okay. I don't like how they went by 5s here, but so that's -7, 3. I'm only concerned with you really having 1 point on each side, so you could go by 1s. Okay, and it's much easier to graph. Okay. Oh, wow. Only 3 problems to do on the side. Okay. If there is no BX, as there isn't number 1, that means it's not shifted left or right. It's only vertically, so it's going to be on the y-axis still. This one tells me it's opening down. Here, there is a BX. This is shifting it right 1. Remember, it's the opposite and the same, which would be +0. So 1, 0, and then it's a negative opening down. That's y equals -3x squared. So if I go right 1, I'm going down 3. 1, 2, 3. Left 1, down 3. Okay. All right. That will do it for this one. That is the last page, right? Yeah.